So let's have integrals. So leading to inverse trigonometric functions. So let's say we or recall in differential calculus, so the derivative of an inverse trigo function. So we have the derivatives of inverse sine function. So that is u prime. So divide it with 1 minus u squared. And then for the inverse tangent, so that is u prime all over 1 plus u squared. And then for the inverse secant, so that will be u prime all over the absolute value of u multiplied with the square root of u squared minus 1. So if we are given a certain integrand which has the format for the derivative of an inverse trigo function, so then that leads to the integral for that given integrand, and the integral will be an inverse trigo function. So if we have an integrand such as du all over the square root of a squared minus u squared, so which resembles the format for the inverse sine, so its integral will be arc sine u all over a. And then if the denominator would be sum of two squares, and then whose derivative of u will be du, so that one resembles as inverse arctangent. And then lastly, so if we have du all over the square root of u times the, or divide it with u multiplied with the square root of u squared minus a squared, so that one resembles as the arc secant. Okay, so we have arc sine, arc tangent, and arc secant. So the only difference of, by the way, our formulas are just limited to 3 formulas, which exclude the arc cosine, arc cotangent, and arc cosecant. Wherein the only difference there, it's negative. Okay, so if we place this one as negative du, then that makes it arc cosine. If we make this one as a negative du, that will make it as arc cotangent, and then if it's a negative d, that would make it a negative arc cosecant, or arc cosecant. In those cases, we don't need those formula anymore, or those formulas anymore. So since if we are just given a negative du here, so we could just have a negative arc sine there. So the negative arc sine is the same as arc cosine. So the negative arc tangent here so corresponds to arc cotangent, and then the negative arc secant is just the same as the arc cosecant. So that's to reduce the number of formulas that we need to recall. So we just focus on the three. Okay. So we just place the negative sign. So for arc sine, arc tangent, and arc secant. So if we have a format which starts or with an integrand which is negative. Okay, so let's try to solve. Okay, so some problems so pertaining to integrand. Okay, so leading to an inverse trigo function. So we'll start with our first example. In determining so which among the three inverse trigo are we going to use, the clue there is we have to take a look at the denominator. Okay, so if the denominator is a square root, okay, it's either it's arc sine or it is arc secant. So the difference is for arc sine, the constant starts, so a squared minus u squared. So u would be the variable side or the variable part of the integrand. And then if it is just a sum, okay, so sum of a squared plus u squared, so that makes it arc tangent. And then if it's the difference and then it starts with u, the variable u squared minus a squared, and of course there should be a u outside the radical sign, that makes it as an arc secant. In this case, it would appear that we have the square root of 4 minus 9x squared. So therefore, so it starts with a. Okay. So in this case, so we designate the constant, so to be the a squared, so which is 4. And then our u squared, so which is the variable, the 9x squared. And then we just need to identify what is a. So a then, so if a squared is 4, so a is just the square root of a squared. So therefore we find the square root of 4, so which is 2. Okay. So squaring both sides, so a squared then 2 squared will become 4. So similarly, so if we have u squared, which is 9x squared, then our u then would be the square root of 9x squared, so which is 3x. And then afterwards, so we need to derive u. Okay, so our u here is 3x, so therefore our u is 3 dx. So in this case, we will be using substitution for the entire inverse trigo, so that we could easily see. Okay, so what formula are we going to use? So in this case, I just need to determine what is dx. So I'll just have du all over 3, so which would correspond to dx. And afterwards, so I can now substitute. So dx is du over 3. So that makes it du all over 3. Then divide it with the square root of, so 4. So this is 4, which is a squared. And then minus 9x squared, so minus u squared. And then we move out the constant, so that would make it 1/3 the integral of du all over the square root of a squared minus u squared. And based on the formula that we had before, so this one resembles the arc sine. So the formula for arc sine, so that would be 1/3, and multiplied it with arc sine of u all over a, and plus c. So we're in our u. So this is our u, so which is 3x, and then our a, it's 2 all over 2 plus c. So that will be our answer then. So 1/3 arc sine 3x all over 2 plus c. Okay, so it resembles the arc sine. So for the second example, so we have the integral of ex all over 1 plus e2x dx. Okay, so in this case, so this is a rational function, and we could not just simply make this one as logarithm. Okay, because once we derive e2x, its derivative is e2x times 2 dx. So it's still e2x, and we cannot get the numerator here. So therefore, we cannot. This is not leading to a logarithmic function. However, so this one resembles the denominator. So sum of squares. Okay, so sum of two squares. So if we could let our a squared to be 1, and then our u squared to be e raised to 2x, so therefore our a, the square root of 1 is 1, and then the square root of e2x, that is e raised to x. Okay, because u squared, so that would make it e raised to x raised to 2, So that is equivalent to e raised to 2x. And then we derive this one. So the derivative of ex, it's ex dx. Then we substitute. So this is the ex dx, so which is du divided with our 1, which is a squared, and then e2x, that is u squared. And again, so based on the formula, so du over a squared plus u squared, so this is the format for that. So which is the arc tangent. So that is 1 over a arc tangent of u all over a plus c. But then our a, so a it's 1, so 1 over 1. Arc tangent our u, it's e raised to x. Our a, it's 1, and plus c. Or in short, that is just arc tangent of e raised to x plus c. So that's the integral of ex dx all over 1 plus e raised to 2x. So let's have another one. Okay, so this is, it would appear that it's complicated, but if we just properly represent each part of the integrand, so this will be easier. So I would see that we have the square root of u squared minus a squared. So it resembles the inverse secant. So in this case, so we have our, so let's say our u squared, so the entire variable, so which is 4 ln squared x, and then our a squared is 5. So to get u, so we find the square root of 4 ln squared x. So square root of 4 is 2. Square root of ln squared x, it's ln x. So 2 ln x squared, so that will be 4 ln squared x. So while for a squared is 5, and then 5 is, does not have a an integer, okay, square root. So in this case, so it's just a square root of 5. Okay, so that's for a. So a is square root of 5. And then we derive u. So the derivative of u, that is 2, and then derivative of ln x, is that is dx all over x. So what we want here is the dx over x. So therefore, du over 2 is the same as dx over x. So let's try to take a look at this one. So what is dx over x? So this is the dx over x. So the dx over x, that is du over 2. That makes it the integral of du all over 2. And divide it with, what is ln x? So this is ln x. And then, so we could have u all over 2, which is the same as ln x. Okay, so ln x, that is u all over 2. So I'll have a u all over 2 here for the ln x, and then the square root of, so 4 ln squared x, so this is the 4 ln squared x, which is u squared. And then minus 5, 5 is a squared. And then we have d over 2 and u all over 2, so we can cancel both. Okay, so 2 and 2 will be cancelled out. So therefore, what remains will be du all over u, the square root of u squared minus a squared. And this one is an arc secant. So we write our formula, that is 1 over a arc secant of u all over a plus c. So wherein a is equivalent to square root of 5, so 1 over square root of 5 arc secant of u, so which is 2 ln x. So this is our u, and then our a square root of 5 plus c. So then we can make that one as ln x squared, or just simply 2 ln x. Then we can rationalize 1 over square root of 5, or we can just leave it as is. So leaving it as is, that would be 1 over square root of 5 arc secant of 2 ln x, the square root of 5 plus c. Okay, so we were now able to use all the three formula for inverse trigo. Okay, so the next one, we have dx all over x squared minus 2x plus 3. So in this case, what is in excess? Okay, so for this particular example is the presence of the negative 2x. So remove the negative 2x, okay, so meaning it would just be dx over x squared plus 3. So right away that is an arc tangent. However, there is a negative 2x. Okay, so there is a negative 2x there. So in cases like this, so we can use completing the square. Okay, so we can use completing the square. So that would make it, remember, so in algebra, so to make this one as a perfect square, so we take half of the middle term. So our middle term is negative 2x. So we get the numerical coefficient, which is negative 2, and then square it. So that is the one that we're going to add and subtract on the denominator, so to make it a perfect square. So 1/2 of negative 2, it's negative 1. Then raise it to 2, that would make it positive 1. Okay. And that is what we will be doing here. So we rewrite this one as dx all over so dx all over so x squared minus 2x, and then so we have 1 here, so we add 1 and we subtract 1. So we plus 1 minus 1, that is still 0, so it doesn't change the integrand. However, it makes the denominator a perfect square. So because this one, so x squared minus 2x plus 1, so that is the same as x minus 1 square. Okay, so x minus 1 square. So the minus 1 there, it came here. So 1/2 of negative 2, it's negative 1. So that's why it's x minus 1 squared. And then negative 1 plus 3, that would be positive 2. Okay, so positive 2. Then, it resembles the arc tangent. Our u squared is x minus 1 square. So our u then will be, the square root of that would be x minus 1, and then its derivative will be dx. So for our constant a squared, it's 2. So a then is square root of 2. So we substitute. So what is dx? So dx is du. All over x minus 1 squared, that is u squared. And then 2, it's a squared. So u squared plus a squared, or a squared plus u squared, that is arc tangent. So 1 over a arc tangent of u all over a plus c. So which is 1 over a square root of 2 arc tangent. Our u is x minus 1 all over square root of 2 plus c. So 1 over square root of 2 arc tangent of x minus 1 all over square root of 2 plus c. Okay, so this is an arc tangent. For example, number 4. For example, number 5, so it has a square root. Okay, but we cannot see anything outside other than the dx. So most probably, so we're assuming that this would resemble into an inverse sine. So again, so what makes this one not inverse sine right away? It's the presence of this negative 2x. So what are we going to do? So the same thing. So we complete the square. So in completing the square, so we have 1/2 of negative 2, then square it. So that is 1 square, which is 1. So that is what we will be adding there. So we will be adding and subtracting 1. So this would be equal to the integral of dx all over the square root of 15. So we add 1, we minus 1 as well, and minus 2x minus x squared. And afterwards, so I'm going to combine. So this would be the square root of 15 plus 1 is 16. And this is for the first two terms. And then for the last three terms, so negative is common to the 3. So I'm going to factor out negative. So that would make it 1 plus 2x plus x squared. So it then follows that I could factor that out. So this would be 16, then minus, this is the same as x plus 1 square. Because x plus 1 squared, that would be x squared plus 2x plus 1. And thus, it already resembles the arc sine. So we're in our a squared is 16. Our a is then 4. Our u squared is x plus 1 square. Our u is x plus 1. And therefore, our du would be dx. Let me substitute. So dx is du over the square root of 16, that is a squared. And then minus x plus 1 squared is u squared, minus u squared. So thus, this one is arc sine of u all over a plus c. So therefore, that is arc sine. Our u is x plus 1. Our a is 4 plus c. So that would be arc sine of x plus 1 all over 4 plus c. So we don't have 1 over a for arc sine. So only arc secant and arc tangent, which has the 1 over a. Okay, so lastly, so we have the x squared plus 6x plus 5. So is x squared plus 6x plus 5 factorable? Five plus 1. A factor of 5 is 5 and 1. So if we add, or if we make it x plus 5, and x plus 1, I'll be able to factor this out. Okay, however, I won't be able to do anything then. Anyway, so we'll be doing the same thing. So I'll get half of the middle term, so which is 6, and then square it. So half of 6 is 3, and then square it, that will be 9. So this would make it integral of 3 dx all over x plus 3, then multiply it with x squared plus 6x, and then we add 9 and subtract 9, so plus 9 minus 9, and then plus 5. So for 3 dx then, so we'll have x plus 3, the square root of, so this one is x plus 3 square. Right, so x squared plus 6x plus 9. And then minus 5 and plus minus 9 plus 5, that would be minus 4. And thus, so we could have our u squared then, so to be x plus 3 square. Our u is x plus 3, our du will be dx. A squared is 4, so a it's 2. So if we substitute that, so we have 3 dx it's du, square divided with x plus 3, it's u, and the square root of x plus 3 squared, that is u squared, minus 4, so minus a squared. So which is 3, multiply it with the du over u times the square root of u squared minus a squared is 1 over a arc secant of u all over a plus c. So that is 3, 1 over a, it's 2. Arc secant, our u is x plus 3. And then our a, it's 2 plus c. So finally, that will be 3 all over 2 arc secant of x plus 3 all over 2 plus c. So that's how we find the integral of a given integrand, so leading to a format for inverse trigo function. Okay, so the trigo function itself, okay, so there is no formula, but we can derive it. Like for example, what's the integral of inverse sine? Okay, so it might need some additional techniques, so which is beyond our topic right now. We'll try to find on how to solve those things. Okay, so once we proceed with other methods of integration. Okay, so far, so this is the integrals. Okay, so leading to a format for inverse trigo functions. Good day.